Okay, we're going to look at topic 3 here, looking specifically at some function values for 30, 45, and 60-degree angles. Those are some special angles. Those angles are not altogether in the same triangle, so what we're first going to do is to construct a 45, 45, 90 triangle. Now, the idea for this is that it comes from if a isosceles triangle. So I need to have, since it's a 45, 45, 90, it needs to be isosceles. So just C in there somewhere. An isosceles triangle has the property that two sides and two legs are equal. Okay. So this side right here, let's call A, has to be the same measure as this side over here. And since those two are the same, I can solve for side C in terms of them. So I've got A squared plus A squared equals C squared. So 2A squared equals C squared. And if I square root both sides, square root of 2A squared equals C. So square root of 2A equals C. So I'm going to label this side C as square root of 2A. Now I can compute the trigonometric ratios for a 45-degree angle. We're just going to do the first three. Sine, cosine, tangent, because the reciprocal functions can be found quickly from them. Okay, so sine of 45 degrees is sine, its opposite, divided by hypotenuse. So that's going to be A divided by square root of 2A. The A's reduce, and then I can rationalize by multiplying by square root of 2 on top and bottom. And so that gives me the square root of 2 over square root of 2 times square root of 2 is 2. Okay, just to restate that since it's so important. The sine of a 45-degree angle is square root of 2 divided by 2. That's where it comes from. And we're going to have to memorize some of these facts. They're going to be on our unit circle, but they are so important that we just need to know these as well. Now the cosine. The cosine of 45 degrees is, okay, if I'm at the 45-degree angle, doesn't matter which one, opposite was A divided by square root of 2A, adjacent will be also A divided by square root of 2 times A. So A divided by square root of 2 times A. The exact same thing is going to happen because I have the same ratio right here. So I should get the square root of 2 divided by 2 again once I rationalize. So the cosine of a 45-degree angle is also square root of 2 divided by 2. Then we have the tangent. The tangent of a 45-degree angle, again, doesn't matter which one. If we look at the 45-degree angle, it's the opposite and the adjacent. So that's going to be A divided by A. So that's 1. So the tangent of our 45-degree is 1. Tangent of 45 degrees is equal to 1. Those A's don't matter. It doesn't matter how big this triangle is. Those ratios are always the same for those triangles. That's a very common triangle. That means that for any isosceles triangle, any triangle that has two sides that are equal are going to have those ratios for their three primary trig functions. Okay, let's check out the next most common triangle. Instead of the isosceles, we're going to construct an equilateral. All sides being equal. Start with an equilateral. So if I make a triangle that has all sides being equal, the problem with this is that I don't have a 90-degree angle. So then we have to bisect it. Okay, so all sides were equal, so they were all A. But now I bisected this, so this bottom right here, this part is only half of A. Right? Now, I still need to know how big this side is, so let's call that B for a moment, and we'll find B in terms of these two sides using the Pythagorean theorem. So the bottom side right here is half of A squared plus b squared equals our hypotenuse, which is still called a, squared. So this gives me 1/4 a squared plus b squared equals a squared. Subtract the 1/4 off, 1/4 a squared off. B squared equals 1 minus 1/4 is 3/4. A squared, square root both sides. B is equal to the square root of, I'll write it first as the square root of 3/4 a squared, but I can square root that piece by piece. So it's square root of 3 over 2a. Square root of 4 is 2, square root of a squared is a. So that gives us the length of this side. It's square root of 3 over 2a. Now, let's find our 3 trigonometric sides. First of all, the equilateral was a 60, 60, 60. Because it had all, that's 360 degrees in a triangle divided by 3, they were all 60. When I bisected it, I cut that top angle in half, and now it's 30 degrees, and I made a 90-degree angle at the bottom. That's how I have this 30, 60, 90 triangle constructed from my equilateral that I bisected. Now I can talk about the sine of each of those, the cosine of each of those. So I'm going to make 2 different lists, one for the sine of 30 degrees, one for the sine of 60 degrees. First, the sine of 30 degrees. So if I'm at 30 degrees, if I go for the opposite divided by the hypotenuse, I have 1/2 a divided by a. That gives me 1/2. If I go for the sine of the 60 degrees, that gives me, the sine of 60 is square root of 3 over 2a divided by the hypotenuse a. It gives me square root of 3 divided by 2. Then if we go for the cosine of 30 degrees and the cosine of 60 degrees. There we go. Okay. So the cosine of 30 degrees would be its adjacent, square root of 3 divided by 2a divided by its hypotenuse. Again, the a's divide out, so it's square root of 3 divided by 2. And the cosine of 60, here's our 60. The adjacent side is the 1/2 a divided by the hypotenuse, which is a. The a's divide out, it's 1/2. Okay. And finally, the tangent of 30 degrees and the tangent of 60 degrees. The tangent of 30 degrees, opposite divided by adjacent, that is 1/2 a divided by square root of 3 over 2a. The a's divide off, and we can multiply by the reciprocal, so that's 1/2 times 2 over the square root of 3. The 2's cancel, and I need to rationalize, times square root of 3 on top and bottom. That one's going to be square root of 3 over 3. The tangent of the 60, okay, opposite is square root of 3 over 2a divided by adjacent is 1/2 a. The a's cancel. That's square root of 3 over 2 times 2 over 1. The 2's cancel. That's equal to the square root of 3. Okay. These happen the exact same way every single time you have a 30, 60, 90 or a 45, 45, 90. So we don't compute the ratio every time and calculate the ratios. We memorize them. So, I want to complete the table with the values that we found so far. Let's fill in the table for the 45, 45, 90 first from our previous page. In the center, for the 45, the sine of 45 was the square root of 2 divided by 2. The cosine was the square root of 2 divided by 2. The tangent was 1. On the previous page, we did not fill in the cosecant, secant, and cotangent, but they are the reciprocal functions. Remember that the sine was 1 over the square root of 2 before we rationalized, so if I take the reciprocal, the cosecant would be the square root of 2. The secant would be the square root of 2. And the reciprocal 1 over 1 is still 1. So now I have all 6 of them for 45 degrees. Now for our 30 and 60. The sine of 30 is 1/2. The cosine of 30 is square root of 3 over 2. The tangent of 30 is square root of 3 over 3. The sine of 60 is square root of 3 over 2. The cosine of 60 is 1/2. And the tangent of 60 is the square root of 3. Notice that there are some patterns here. The sine of 30 is 1/2. The cosine of 60 is 1/2. These are called cofunctions. They are not the same as the reciprocal functions, but there are some patterns there where they are related to each other because they're built upon the same triangle. Sine of 30 and cosine of 60 are cofunctions. We'll talk about those as we get to the patterns right here at the bottom. Okay. Now I need the cosecant, cotangent, and secant for each of these. So if I have 1/2, its reciprocal is going to be 2 over 1. If I have 2 over the square root of 3, 2 over the square root of 3 rationalizes as 2 square root of 3 over 6, which reduces to square root of 3 over 3. Oops, sorry, that's a regular 3 down there. I accidentally made it a 6. It was real 3. So I meant to say the secant rationalizes as 2 square root of 3 over 3, and that can't be simplified. So the secant value is 2 square root of 3 over 3. Then the cotangent value, if I take the reciprocal of the 1 over square root of 3 here, it's going to be back to the square root of 3. Okay, now over here, 2 over the square root of 3 is going to rationalize again to 2 square root of 3 over 3. And then 1/2, reciprocal is 2 over 1. The square root of 3, 2 square root of 3 over 3 will simplify. I'm sorry, I'm looking at cotangent. Square root of 3, 1 over the square root of 3. Simplifies back to square root of 3 over 3. There we go. Square root of 3 over 3. Okay, so we see some more patterns right here. Tangent and cotangent, we didn't mention cofunctions yet, but we can see them now popping in because the tangent of 30 and the cotangent of 60 are cofunctions. So we see some additional patterns happening there. And then we also have the same type of patterns with our cosecants and our secants that we saw before with the sine and the cosine. So there are some patterns there. And then for the sine and cosine at 45, I have less to remember because they are going to group up with each other as well. So, do I notice any patterns in the values above? There are so many patterns, but those can help us remember them. There's going to be another piece in the next couple pages that are going to talk about cofunctions and reciprocal functions as well.